Okay, hello students, good morning. Again, welcome back to this discussion. So last class we are discussing the von Neumann architecture. So now today again I'm repeating this von Neumann architecture. So von Neumann architecture, what I said in the last class, it is a mathematician who developed this, modify the storing concept of the data within the memory. So what I'm discussing that now the data and the instruction are stored in one place of the memory. Either in the data is stored within that area where the instruction is stored, or if data is stored in another area of the memory, that reference address is stored near about the instruction. That what will happen, and that is the problem. It is the minimize the accessing time of the processor to retrieve the data from the memory. Next is that's a two unit, input unit and the output unit. Devices, input and output devices are connected with input and output devices respectively, and that is the central processing unit. It is the combination of the control unit and the arithmetic logical unit. There is another registers are used in this unit. There are so many numbers of registers are used in CPU, but there is important thing is known as the accumulator. That accumulator is a register which stores the data for the temporary purpose. So why the registers are used in this central processing unit? Because there this acts as a local memory for this central processing unit. Control unit control the entire process system, that is arithmetic and logical unit is there. So what is the job of this arithmetic and logical unit? Now the job of the arithmetic and logical unit is that it operates your tasks. If it is arithmetic, then it is completed by the arithmetical unit. If it is logical data, then it is completed by the logical unit. So how it is identified by the control unit, which one is the arithmetical part, which one is the logical part. So the basic operation that when your task is coming to the computer, that means suppose the example x plus y. So in the x plus y, which part indicates that which type of operation this. That means your plus is a signature, is identification that this is the operation, that is an operator which identify, or it is the motivation of this task, right? Now so x plus y. So when the control unit first fetch that plus instruction, that means by using that plus signature, it is confirmed that it is arithmetical operation. Because which are the arithmetical operation? The operation under the basic mathematical operation like mathematics, your plus, addition and division and multiplication. So that signature is only identified which type of operation this is, right? Now similarly, suppose you are writing if a greater than b, or if a is greater than equal to 18, then the peoples are eligible for voting. So such type of decision thing, bit operation and equal, these are the bit operation, right? This tends to the logical part. So that logical unit is entered into that's logical bit operations. Decide that now this is a logical operation. Now so control unit send this type of operation to the logical unit, right? And so this is the phenomena of the von Neumann architecture. And the number of the register, like the accumulator is in single register is there. Why? Now generally there is a memory unit and this is the central processing unit. So what will happen? Now generally when you input you supply the data through these input devices, data is stored in the first memory unit. But here problem is that now the time taken by the processor to retrieve the data from the memory is very large. So that's why suppose you are maintaining a calculation like a plus b plus c into d plus e into a plus a. That means here in the series of this tasks, the first the output, that means the answer, that means a plus b, the answer of this a plus b is the input for the next operation. That means central processing, if central processing unit have no storage capacity, that's why the data definitely move to the memory area. So problem is that to accessing the data from the main memory by the processor, it is too long time. So to minimize that thing, the number of the registers are present within the central processing unit. So here what is the register? Now register is nothing, it is a memory area, but store the data for the temporarily because it is very small memory. Right now it provides instant service to the central processing unit. So in that case, suppose A plus B into D plus E plus F plus 6. So first A plus B, whatever the result will be stored in a register in place in the memory unit. Clear now? Because to retrieve the data from the register by the processor is very fast compared to the main memory. So is data, the output data is stored in the register, then after manipulation is totally over, then the entire data will be stored in a register or at the main memory area. So that's why the number of the registers are used in the central processing unit. Clear? So this is about the von Neumann architecture. Next is this is the block diagram of computer, and it is also it is a long question in the semester exam. What is the block diagram of computer? And the block diagram of computer, this is the input unit, this is the output unit, and here the storage unit. Storage unit means your memory unit. This memory unit is divided into two parts, primary storage and the secondary storage area. Primary storage area means it is a primary memory or it is a main memory where the data is stored for temporarily. That means when you switch on the computer and starts its work, it is the primary memory area. That means data is stored in the temporary area. What is the volatile in nature? Volatile means when your computer is to stop to work or in case power is off during the working time, then the data is also erased automatically. There is no permanent retain capacity of the data within that memory area. This is the primary area, memory area. Next is your secondary memory area, secondary storage. And in secondary storage, data is stored permanently. That means after saving the data from the primary storage, the data is transferred to the secondary area. Clear now? So that is known as the primary storage, and all about the primary storage and the secondary storage. Secondary storage area is a purely non-volatile memory. Clear? It's purely non-volatile memory area, and this the data is stored for the non-volatile means it's the permanently within the secondary storage area. So input unit and output unit, the two unit. Next is your control unit and the ALU or arithmetical logical unit. This control unit control the entire system, and arithmetic and logical unit control the operational system, arithmetic and the logical operation. Clear? So next is your input devices. Now discuss about the input devices. There's so many numbers of input devices are used in your computer system. The first on this queue is the first is your keyboard, right? So what is the keyboard? Keyboard is the input device. It is two types. One is your wire-based, another one is your wireless-based. Generally the standard keyboard, this type of keyboard which is seeing in the picture, generally contains the keys from 104 to 108, and the laptop computers use the keyboards is 97 to 100. Numbers of keys are there, including the functional keys, special keys is there, and this keyboard is used to supply the data from the external environment to the computer system, right? So let's get a focus how the data is moved towards the computer system. Suppose you press A character in your keyboard. That means a signal is created from that key and moves through the wire or wireless medium to the computer system, right? The computer system diagnoses that signal, which type of signal. It is a character or it is integer, because your keyboard having the alphanumeric characters there, characters are there, and the numerical characters are there. So which type of character is this is identified by this through this signal, and according to that it will be produced on that screen. So that is the job of the keyboard. Next is mouse. Mouse is another input device. It is two type. One is a mechanical mouse and one is optical mouse. Today's generally optical mouse are used. There is no mechanical mouse. Optical mouse means there is a sensor, there is a light beams concept is there, there is a lens is there, through which you sense the signal, the beam of light, and according to that the cursor is movement occurs. That means from forward to backward, the backward to forward, the movement will be occur. That is the mouse concept. So in the mechanical mouse, but nowadays mechanical mouse are not using, there is a bulb in place of the light beam, right? And the bulb is rotating. As the ball is rotating, according to that the cursor is moving from one point to the another point. So that is known as the mouse. Okay, so today in this much for discussion. The next class we will discuss on the another input devices. So thank you to all.